Okay, this is the shopping cart project open in Modelio. In the shopping cart welcome page, we can access the project's portal. Users, wherever they connect from, can visualize the latest news, the project structure, the users, activities, and history of the project, as well as links towards the bugs and their evolutions. So we open the project in Modelio. And here we are. So as indicated during the presentation, we have several model fragments. The access rights change in accordance with the users. As a Java developer, I can't modify the requirements or architecture fragments, which is why they appear in gray. I still have read rights on them, so I can link Java elements to the architecture or the requirements. And those links will be used to analyze the impact that the evolution of the requirements has on the development. Just like Eclipse or any other IDE, you can see the code structure with packages and classes. You can generate the Java code from the model. This class diagram, for example. The diagram graphically shows classes, attributes, associations between classes, operations, and so on. The Java file corresponding to the catalog class can be displayed in Modelio. Now, the elements descriptions are produced as Java docs. The association between the catalog and its products is produced as a product list, which we can see here. In round-trip mode, you can either modify the model in Modelio or modify the Java code. For example, developers will generally work in Java files, while architects will prefer working in the model. The code and the model are synchronized at all times. For example, in the Java code, if I add an attribute that I name version, as soon as I save the Java file, the model is updated. I can also add a constructor directly in the Java code. And here we are. Now, if I add a new parameter to this constructor, and the initialization code of the new attribute in the constructor, then upon saving the file, the code is also reversed in the model. And this way, the whole Java source is integrated in the model. If you prefer to work at model level, you can add a new attribute to the catalog class. For example, let's call it its creation date. Okay, and generate the code. Once the code has been generated, an import towards the Java util date class is generated, along with the attributes of that type. Now, all the libraries used by our project have been modeled. It is easy to create links towards those elements. The whole JDK is modeled, for example. You can see the classes that it contains, the interfaces, and operations to implement. In our example, we'll create a generalization link from the catalog class to the JDK's dialog class. So I just need to search for the class using the advanced search feature, unmask it into a diagram, and then create the link. Okay. If I generate the code, we can see that the code generated by Modelio shows the extends dialog and the import. But of course, developers keep using Eclipse to write code. So let's start Eclipse on the same project. Modelio generates the Java code in the Eclipse workspace. We'll use Eclipse to fix a compiling error on the constructor. There are no restrictions for developers working on Eclipse. For example, they can create classes, rename them, or move elements during refactoring operations. During the synchronization, Modelio will update the modeled elements. For example, let's rename the attributes creation date. Okay. In Modelio, I can explicitly update the model from sources, but if I regenerate the code, Modelio will detect that the Java catalog file has been updated and offer to update the model. After confirmation, we can see the model was updated. Now, to let you visualize any kind of links, Modelio offers a dedicated tool called the link editor. You can see that the links that have been created appear in the link editor. The catalog class is in the center. The inheritance links towards the dialog class and the association towards the product class are there. In this diagram, it is also useful to see which classes use the catalog class. For instance, here, Online Store uses it. So let's change perspective to reorganize the different views that Modelio offers and place the link editor at the center. Looking for a composite class in the SWT library, we can see the whole inheritance graph. The editor also lets me easily create links between elements. When I drag and drop a requirement into the editor, Modelio offers to create a traceability link. So I just drag and drop the element here, and there's my link. This way, in the next version of this application, we'll be able to know that the evolution of these requirements will impact our catalog class. The link editor also displays the dependencies between elements, for instance, packages. If I select the online store package, you can see there's a dependency between this package and the package named products. If we run the show details command, we can understand the causes of the dependency. There are 4 reasons explaining it. For instance, the associations between classes catalog and product, or the use of product by an operation parameter of the catalog class. In the Java tab, Modelio lets you add Java properties to model elements. This tab contains buttons that lets you generate code from the model, update the model from existing code, or edit the Java files generated by Modelio. For each type of element, the no-code property can be used to exclude the element from the generated code. If the attribute has to be static, just check the static box and you can visualize the new state in the model as the attributes now appears underlined, which is the UML standard for class attributes. In the Java code generated by Modelio, the keyword static is added to the declaration of the attribute. To generate the accessors, I just need to check the getter or setter properties. The accessors are then created in the model. Now let's generate the code to see the changes. Now if I rename the attributes, its accessors are automatically renamed. Here we are. But to avoid impeding the model with technical operations like accessors, it is possible to generate them in the code without creating them in the model by checking the Java property tick box. You can then choose which accessor has to be generated, as well as its visibility. For attributes which type is a basic type, checking the wrapper property will lead to generate either the basic type or the corresponding wrapper class. For example, the type integer with a capital I is generated instead of the type int with a lowercase I, all without changing the model, and the accessors are also updated. By default, the generator is set to generate the associations of cardinality 0 to many as array list. It is possible to modify that behavior globally for the whole generator by modifying the configuration file or just locally on a specific association. In the collection to use field, you can specify the collection to be used for the current association. For example, I could choose linked hash set. Now, Modelio can automatically generate methods such as equals, hashcode, and toString. Also, these methods are always up to date. I'm going to create those methods on the catalog class in the model. Then generate the Java code for the class. And like in Eclipse, the code of these methods is written from the attributes of the class. Now let's add a name attribute to the class catalog. As soon as I regenerate the code for the class, the equals, hashcode, and toString methods are automatically updated. It is not necessary to explicitly update them like we should have done in Eclipse. Modelio automatically solved the frequent problem of desynchronized methods and class properties. Of course, Modelio offers a reverse feature to build a UML model from Java sources or jar libraries. Let's take Java sources that were not generated by Modelio, but downloaded from the internet. They correspond to examples of the use of the SWT library. The wizard let me choose the sources to reverse. And then when I hit reverse, Modelio will analyze all the files and then reverse them. This operation can take a few minutes, as Modelio will build a whole new model at once. So we can see it's parsing through the elements. And here we are. The elements are here, and the small sign, plus sign, indicates that the elements are new to the project. Now the Java code can now be generated from Modelio, including the ones that I just reversed. In Eclipse, we can see that the sources generated by Modelio will compile, and the Javadoc has been reversed as description notes in the model, then regenerated as Javadocs, and no code was lost during the reversal. Modelio also offers a feature that automatically creates graphic representation of the model diagrams. Now let's run the command on our project. During the operation, which can sometimes last a few moments, Modelio creates different kinds of diagrams showing either the element structure or the dependencies between the packages. For example, on the online store package, we get a dependency diagram that shows the dependency links toward other packages, clients, types, or products. For the catalog class, we also get a diagram that shows the structure of the class. Now, Modelio comes with an advanced Javadoc generation feature. Automatically created UML diagrams are included in the Javadoc. Let's run the Javadoc on our project. This can take some time depending on the size of the sources. And here's the result. We can see the catalog class, and it is possible to browse the product class to the product class by simply clicking in the diagram. On the online store package description, we can see the dependency diagram created by Modelio. Unit tests are also synchronized with the model. From our model, we can automatically create a test class and test operation for the JUnit framework. Once we've generated the Java code for the test model, we can execute tests in Eclipse. By default, Modelio will generate a failure test. Of course, the test code is not implemented by Modelio and has to be written by a developer. It is also possible to add new test methods for the operation of a class, and thus test several cases. Or simply to rename the existing ones. Once we have produced a technical documentation in the form of a Javadoc for developers, we can produce analysis or design documentation for architects thanks to the Document Publisher module. All our documents are stored in the Documents folder. Several kinds of documents can be produced, a specification document or a test plan containing all the tests. Once the document has been defined, I just have to launch the physical generation of the documents. The whole Java model is described, with diagrams, dependency diagrams, structure diagrams, tables, showing sub-elements, the contents and formatting can be adjusted, so the documents fit the company conventions. Here we are. These are the diagrams. The tables showing all the elements. And that's our catalog class. Modelio offers the possibility to retrieve the contents of documents. All the elements extracted from the Modelio repository can be modified in the documentation, like the name and description of the elements. For example, I've modified the description of the catalog class. Now, to retrieve those modifications and update the Modelio repository, I just have to save the documents, then go to Modelio and run the update command. A report shows the modified elements, and here's my new description. Then, if I regenerate the Java code from the model, I'll be able to see that the new description has been added to the Java doc. It is also possible to generate the documentation in HTML, in which case browsing through the document is even easier using the hyperlinks.